possible. All right. So most time it could be hot air sterilization, moist heat. We have dry heat. Okay, in terms of between moist heat and dry heat, moist heat has more advantage. Okay, I'll explain why. Dry heat ni just haba kering saja. Okay, so when it comes to dry heat sterilization, we have the call first one red heat. Betul tak red heat tu apa? Any idea what's red heat? Anyone?
Api yang dipanaskan sampai merah.
Api yang dipanaskan apa?
Sampai merah. Macam dekat besi
Sampai
tu.
merah. Ya, sort of. Dalam kelas ni ada Amalia je ke? Where's the others? Korang ni. Kalau I tak ada dalam lab, memanglah seronok kan? Luckily you have lab with me this week. Not this week, next week. Still have like how many weeks? We still have like 11 weeks, guys. So, siapa-siapa yang senyap, lagi kacau dalam kelas. Okay. Red heat, usually this kind of heat is like something you heat up over the flame of Bunsen burner like in our cases. Okay. For example, I think I've showed you on the first week. Remember the loops, the needle, the loops, striking loops, all these kind of like metals. Those bila kita panas ke atas Bunsen burner, which nanti tomorrow Kak Teha, Kak Tina and Nadira will demonstrate all to you guys in terms of how to do it. Okay. Is when you panaskan loop tu akan jadi merah, right? That's called dry heat lah. That's because there's no moist involved. Okay, so the idea is kita nampak merah, then we know that oh ni dah panas and very is burning. So most likely benda ni there's no micro UV involved because it's only really high heat. Okay, when flaming ni bukan you macam bakar. Flaming ni is like you lalukan api. Okay, for example you have a Bunsen burner. Nanti tomorrow Kak Tia will show you some demos. Okay. Just imagine it is a Bunsen burner, right? So you have a Bunsen burner. Ni dia punya burner, dia punya tiang tu, and you have api here, right? Just imagine there's a fire here lah. Okay, here, and then you have usually you have a media bottle. Okay, just imagine this is a media bottle. Okay, this is called flaming sterilization. It's not very effective. Push. Okay, crap. Sorry, it's not very effective, but it's somehow reduce the possible of contamination. Bila you buka bottle tu, okay, in the media tu macam ni, in a bottle, right? Okay, this is in the media. Okay, inside here, the media itself is sterilized, it's non-contaminated. But outside here, when exposed to environment, like I think Dr. Ni have taught you before, micro is omnipresent everywhere. Literally everywhere. Okay, so basically all the things that expose bottles, hands, and everything, the caps, even inside here, there's a growth of microbes that we can't see. Okay, if we open this, there's a chance whereby it could go in. So the first thing we want to do every time we're handling media, we have to deflame here. We have to lalukan api, or call it flaming, the bottle, so that this somehow will create some sort of sterilization area. Okay, so you have to understand when you do any kind of lab work, like I said, kalau properly, we'll do it in biosafety cabinet, BSC call it. The one yang kat belakang ni, I want to show it to you, is at the back on my left hand side or on your right hand side, belakang corner kiri tu. Okay, yang ada safety cabinet. Okay, usually experiments, microbes, we will do it under there, because since you are ramai, kita ada very limited amount by SafeNet. So the other thing that we could do is we create some sort of sterilization punya area. Okay, we have a Bunsen burner. Okay, it's mainly a Bunsen burner and api. So this area, I think, I'm not sure what's the measurement. I think it's in online. I think it's about 10 centimeter diameter. Okay, about that much. Just imagine this 10 centimeter lah. 10 centimeter. Within that 10 centimeter diameter from the Bunsen burner flame, all right, that's called sterilized area, because that area is hot. Most likely, organism would not normally survive. It's there's a chance of contamination, but we reduce the possibility or likeliness that the contamination would occur in the area. So anytime you do your experiments, streaking a plate, open your plates or open your media, that will be close to the flame. Not bakar ni flame, you bakar tepi dia. Bukan ni ya. Kita lalukan saja ke api tu. Okay, slowly. tomorrow, you'll get much more better idea when you do the experiment tomorrow. Okay, they will show it to you. Okay, hot air oven. Okay, this is oven lah, but it's more kering. Tak macam baking punya oven tu, that's hot air. Usually you can use all this macam apparatus, okay, those yang could withstand higher temperatures. Okay, your glassware, metal containers, water-free oils. Because we don't have kita nak ada boiling of that one, because any kind of boiling will cause some pressure build-up and other compounds that can have high boiling temperatures. Okay, then we can do that. Okay, these all have all of these have different kind of different level of you punya sterilization. Okay, but everything, all of it is effective. Okay, this is what I said, that temperatures, okay, as the temperatures go higher, increase on temperature, the time will get shorter for sterilization. This is for dry heat, yeah. Okay, there's no moist that being involved. Okay, so usually Rytec is heat tolerant wrapping method. Macam kalau you nampak all this lab system kan, you punya loops and everything, dorang akan balut benda tu dalam aluminium foil. Okay, this is to kill all the microbe. At the same time, after you finish you punya sterilization tu, whatever dalam container of aluminium foil tu will stay sterilized. Bayangkanlah you dah ada, you just masukkan you punya loops and glassware, kosong terbuka macam tu, okay, that's right. And then you bawa keluar, expose balik to the environment. So now it's contaminated already lah. So everything has to be covered and wrapped. Okay, after you finish your punya sterilization, you take out, that one is still sterilized. Because dalam area of that container tu still sterilized. Okay, what I mean? Okay, good. Okay, moist sterilization. This is very easy. Okay, this is what I'll show you to autoclave. Okay, your autoclave is your moist sterilization. Like I said, if you still remember, or those some of you did not come on the first week. So moist sterilization or autoclave is similar to your pressure cooker. Okay, it involves moist water, build up pressure, at the same time it has high heat. Okay, so normally if you notice that here, okay, for dry heat, you have to go for about 180 degrees or possibly more than that to achieve sterilization in this short amount of time. But for this one, okay, that show time. Yeah, usually when it comes to pressure cooker or autoclave, you have this kind of pressure. As the pressure go higher and temperature go high, it become much more shorter. It could go to about 3 minutes to 5 minutes or even less than that to achieve complete sterilization. Okay, this one, yeah. Most microbials sterilized 10 to 15 psi here. 1 bar gauge, pressure about 1.4, 1.5 kilogram per centimeter cube. Okay, for 15 minutes. Okay, but as you go higher, it could go more lower. Some I think it's about 5 to 8 minutes. Okay, so cukup. But however, 15 minutes ni is like not from start to the beginning to the end. No, 15 minutes is happen when you achieve this pressure. Bila you achieve the pressure, then dia baru start timer. Okay, sama macam pressure cooker. Bila masak, has anyone ever handled pressure cooker before? Masak nasi ke, masak daging, whatever it is. Pernah tak tengok? Or your mom operated and you seen it? Have you seen it?
No.
Yes.
At all?
Tak ada pressure cooker.
Tak ada pressure cooker lah, Norman. Murah je. 300 dah dapat dah. Suruh mak beli. Masak nasi pun kejap je. 5 minit dah siap dah. Alright, so basically pressure cooker, same as autoclave, it will require some time, alright, some time for that pressure to build up. Okay, because pressure cooking, you have to completely lock the autoclave sama juga. You have to completely lock the whole environment. Since there's a moist, there's a water there, that you create a pressure build up. So once the pressure build up achieve to what you want it to be at 10 to 15, macam pressure cooker, the stick. Okay, macam autoclave, you can set the pressure, okay? 10 to 15, once it reach 10 to 15 and this kind of temperatures, it will start the counting. Right? Once you finish, then it's finished. Kalau you perasan, bila you keluar all this apparatus or glassware, bila you keluar, memang ada macam ada basah-basah dalam tu sikit. It's fine, they will dry out. But yeah, that's the reason for why I call moist heat. Okay, and it's very effective as compared to your dry oven heat. Okay. So this one I think you can read it on your own. This is just how to operate. I don't think you will operate at this point, but you might most likely operate in your final year project. You have to do it on your own. So one of the most important thing that you have to ensure that you have to have sufficient water inside the chamber. Sama juga. Kalau macam pressure cooker, you don't need add water because usually dalam tu memang kita tak air, right? Macam autoclave ni, memang ada side tu kita ada tangki. You have to fill up the water and make sure the water is at sufficient, macam ada minyak lah, ada gauge lah, at sufficient level. Okay, so once you load it, like I said, nanti macam usually you load it macam dalam raga besi tu, in a metal basket. Okay, whereby you put all your apparatus, glassware, your media in a bottle. So you put it over there and you load it. Okay, so once you dah letak everything in metal basket in your autoclave, you lock. Dia lock tu sama macam you punya pressure cooker ataupun macam peti besi. Completely locked. There's no air getting in. There's no air getting out. Okay. Dia macam ada gauge, and your autoclave usually ada macam gauge of release pressure. Okay. If emergency ke, if the pressure below is too high, okay, you can have that emergency gauge to open up. Okay. So the rest you can read on your own. It's basically pretty basic. Okay. And the third one is your filtration. Sama je. Ini konsep dia, there's no heat being involved, but it somehow relates to your sizes. Okay, size of microbes, size of any contaminants. I'm not sure whether they have able to do filtration on virus. I doubt it so, but most bacteria and spores are able to filtrate it. Okay. This is what the technology being used for nowadays. It has been advanced. Kuku, Kowe, they have actually revolutionized how the filtration works. Okay, so basically they just filter whatever it is that being needs to filter. Okay, so they have different type of filtration. In dia punya filter tu ada sizes. Okay, very very small from microgram to nanograms. Okay, usually when it comes to advantage of filter ni, you have to have a high pressure to push out your water or your media, whatever you want to sterilize. Okay, your filter ni have to be usually media lah. Unless you punya air filter tu lain lah. When we're talking about media, not in a sense whereby you can filter your apparatus or glassware. It's not possible. Usually we do this in terms of separating some compounds, or you want to have distilled water, those kind of case, or you want to have apa nama ni? Filtrate your punya media, especially when it comes to media that is very sensitive to heat. Okay, kalau you heat the media to maybe damaged or destroyed, so all you have to do through filtration. Okay, so this called membrane filtration. Okay, you punya membrane tu depend. Ada yang consumables, pakai buang. Ada yang macam you boleh recycle. Okay, some of the recycle can be sterilized. Macam this one. Okay, right. Some is pre-packed sterile membranes. Okay, macam dah ready, right? Membrane tu nanti I think they will show it to you. Sides filter, okay, this what called asbestos plate, okay, used for filtration or filtration large amount of fluids in the wine, okay, beer industry, in antibiotic industries, okay. So usually when it comes to this one, you get wine, beer, and antibiotics. All of these are somehow could be somewhat sensitive to heat. If you heat it up, maybe dia punya compound taste destroy, ataupun antibiotics and compound tu will be somehow inactivated. Okay. Okay, this is sintered glass, sama juga. Okay. It's a certain type of filtration, and then you have this one. Okay, I think this one you will show in the lab. You have two parts. Okay. Ni tempat loading area dia, okay, whereby you can, this one is similar to top load this one, okay, whereby you can load your media here, water or media, whatever you want to filtrate, and in between here, tak nampak, nanti you see in the lab lah, I think they will demo it to you. In between here, you will have a membrane filter, which you can differentiate between different sizes. Okay, I think nanti when you come into the lab, they have different kind of membrane sizes. Okay, that membrane size, as the membrane size smaller, meaning dia punya pore to getting smaller lah. Okay, usually you will clamp it this one and a parts of this one. There are second part. There are three parts. One, atas top second part, whereby this after the filter, and this is the glassware or beaker, conical flask, where the collection area. Whereby here, you see the muncung kan? Kita tak ni untuk apa? You have any idea for what this one? To connect what?
Vacuum.
Huh?
Water.
To connect what?
Don't know.
Any idea?
Is
a
it to evaporate the water?
We don't evaporate the water exactly. We need the media. We just filter it, but not evaporate it.
As an
Any idea?
adapter between load media and conical flask?
This one tak, this one. This connector ni, muncung ni, okay? This is for what? Mariam? Where are you,
Me?
Mariam? Yeah. What is it for?
Is it maybe for like connecting like a vacuum tube?
To what?
Like in the vacuum tube that
Yeah,
sucks
pandai.
the.
There you go.
Oh, okay.
Exactly. Good girl. Right. So the media over here, you can load the media over here and it will drip. Okay, it can go, but it will be very, very slow, yeah? Because there's no added pressure here. There's nothing. It could pass tube and it will vacuum, where this will suck up your media and it will, because the filter is just too small, okay, for water to pass just like that. Unlike Kowe tu filter dia very small, very, apa nama, the filter is quite big lah, some is very small, but still you have added pressure coming from the incoming water. Macam this one, you just load your media macam tu, because it doesn't have any added pressure. So you have to create pressure here, vacuum it, and then the media will be transferred here. Okay, so whatever in the collection area here, this is somehow considered sterilized media. Okay, good. Irradiation. Okay, some of it is we use irradiation. We use gamma ray, UV, electron beam. Okay, this is considered as non-heated process. Okay, I think nanti Dr. Ni akan, I'm not sure whether this semester or next semester, this is one of the methods of sterilization. Okay, irradiation, one example is your microwave. Okay, microwave is involved the form, or it doesn't employ heat, but it incite radio wave that would cause your particles to vibrate and will cause heat. I think, sorry, this will write is somewhat radiation lah. Sorry, microwave, radio wave. Okay, let me get this right. Okay, microwave is not actually irradiation. Sorry, microwave is considered under heat. Sorry, considered under heat. But the idea is somewhat similar. Contoh irradiation is, okay, your biosafety cabinet, right? You punya biosafety cabinet, if you notice, I pernah on the lampu biru tu. Yeah, that's UV. It doesn't involve any heat. You punya gamma ray pun sama. Kalau you pergi ada certain companies or food manufacturers whereby kalau you nampak ada macam gamma ray punya symbol, meaning that that particular food has been processed not through heat but to gamma ray. Electron beam pun sama. Those are the kind of things whereby it doesn't kill the microbe through heat, but it kill the microbe through radiation, whereby this radiation would attack its DNA. Right? If the DNA is broken, then they will die. Okay, without DNA, any of microbes will die. Macam kita, UV light from sunlight, if you berjemur hari-hari, there's a chance whereby you will get skin cancer because there's somehow irregularities or breakage of your DNAs that cause your cell to mutate and it can create a cancer. Not to become a mutant or X-Men, yeah, in some per se, but it can cause a skin cancer or any kind of cancer. Okay. All right, sterilization with the gas, ethylene oxide. Okay, sama. This kind of gas will, but it would damage any kind of microbes. Okay. Formaldehyde. Formaldehyde is actually not. Some is liquid, some is vapor. This usually on terms of food processing or apparatus or glassware, but as some cases whereby we found formaldehyde in traces of food, traces of formaldehyde in food. Ada orang guna format to increase the shelf life. Yes, it is very effective, but it is very, very deterrent to human health. Okay. All right, here you go. Now we go into disinfections. Okay, usually disinfection will involve chemical use. So usually chemical disinfection is used for heat sensitive equipment. That is usually damaged in high temperature ataupun something yang tak boleh masuk dalam macam oven or this size too big. Okay, for example, katakanlah macam you punya bench work. Macam ni nak angkat letak dalam autoclave, this is not possible, isn't it? So the only thing that you could do, takkanlah you nak bakar meja tu. It will get destroyed, doesn't it? So all you can do, the best is you can do is to get alcohol and wipe and clean. Same goes for our hands, same goes for the rest of our body or any kind of medical apparatus. It's too big. Macam food processing got, we call it disinfection. Macam all your pipelines or processing line of you're making foods or making your biscuits, your proper or kind of sausages and everything. You can just leave out the whole thing, masuk dalam microwave or disassemble, masuk dalam autoclave, disinfect it. It's just not possible. So what I can do, they have a chemical reagents to use, and every now and then they will have scheduled disinfection to make sure everything is clean and not being contaminated. Okay, so this is an example of ethyl. So it's not just related to heat sensitive, but it's something that is just not possible to be included in your ovens or autoclave. Okay, so ethyl, isopropyl alcohol, quite ammonium compounds, and glutaraldehyde, different kind of types. Okay, of chemicals. Banyak lagi. Okay, some of it nowadays they use essential oils or some oils that is considered as antimicrobial agents. Okay. So the timing, method, chemical disinfection factors affecting the efficacy of germicide and hazard posed by the use and consumption. Meaning that, okay, so basically, between ethyl, alcohol, quat ni, all of this is not similar. It's not sometimes you can use this 1% for ethyl or alcohol, maybe 4% for quat at 40 degrees Celsius or 60 degrees Celsius. How long? Maybe for 5 minutes, or 6 minutes, or 10 minutes. So depending how you do it, depending what sort of thing that you want to sterilize, and depending what sort of agents or chemical agents or disinfectant that you're using. All that vary from one chemical reagent to the other. Some are more effective than the other, some are less effective, depending. Some is equally effective. Okay. There you go. This is factor affecting efficacy of disinfection. So concentration, formulates how it's being formulated, what's the active ingredient and compound, what's the target organism, are you trying to kill microbes or fungal or yeast, or you want to kill spores. So you have to know. So you have to know what sort of thing that usually contaminate your target punya your areas or your processing lines. So if you need fungal, maybe you have to use much stronger one because fungal is much more harder to kill as compared to bacteria. Contact time, berapa lama nak letak? Nak apply 5 minutes, 3 minutes, 2 minutes, 10 minutes. Temperatures, okay? How many level of temperature? 70 degrees Celsius, 60 degrees Celsius. Hot water. Hot water ni we relate to the how amount of water is being used. Okay. Soil load mean that if the presence of soil in your processing line, okay, that will somewhat affect how you're using your disinfectant. Biofilm. Biofilm ni, you know biofilm, right? Yang sort of macam like a wax. Okay. Biofilm are actually is much harder to kill than your microbes. Okay. Sometimes biofilm is not you punya microbe pun, it's just dia punya discharge of the microbe, dia punya lendir dia. Right, so called. Okay. Surface microtopography, how you surface you punya permukaan tu rata ke tak rata ke, processing line tu macam lekuk ke, ada macam all these differences of you punya shape of your things that you want to clean. Pre-cleaning, sometimes before you disinfect, they might have some pre-cleaning procedures. Maybe you use hot water ataupun you use some sort of acids first to clean it. pH, of course, some pH are disinfectant are varied from pH to pH. Some are effective against high pH, alkali pH, some effective more acidic pH. Humidity, okay, your moist activity at the time, comparability, okay. Maybe sometimes you punya disinfectant tu is not suitable for woods, you cannot use that. Maybe some things you punya disinfectant not suitable for metals, it might rust the metal, it might corrodes the metal, so it's not being, it can't be applicable. So you have to know the compatibility. Application method, okay, whether you apply immersion, tenggelam, flooding. Immersion tu sama flooding tu macam you flooding ni, immersion tenggelam, flooding ni you basahkan dengan big amount of water, brushing ataupun wiping lap. Okay, so you have to know how the method works. Okay, application rate, this in terms of, okay, how many times you apply these disinfectants at your area. Maybe you do 1 coat, 2 coats, 3 coats, or you do first dose, second dose, like, okay, you have to do it today, and the next time we have to leave it for about 12 hours, and then we do it again, different coatings. Okay, storage, okay, in terms of disinfectant, you have to know how to store at room temperatures, normal temperature, room temperatures, or at slightly high level temperatures. Okay, and then of course you punya product age, you have to know the shelf life of your disinfectants. Sama juga, all things have shelf life. Okay, you have to know how long it will last. When it comes to shelf life in disinfectant, bukanlah dia basi, right? But it's we go as the shelf life getting much longer, the bioactive, the compounds, or the active compound that needed to kill the antimicrobial compound would somehow be degraded. So it's not as effective as it should be. Okay, if it's past your expiry date. Okay, this one you can read on your own. If it's target skin, blood, urine, they have different kind of disinfectants, percentage of different disinfectant used, how to apply it. Okay, 2+1, this term of water, direct. Okay, ni water ratio lah. Okay, this is time exposures. Okay, berapa lama you apply? 2 minutes, 6 hours, ada hours and ada minutes. Okay, ni feces, tahi, blood, urine. Okay, you all know this. Usually this thing is kind of more common in hospital lah. When it comes to this, okay, macam ada spills of blood or urine. Okay, ada kat katil tu, this is how they do it. Alright. Workbenches, very simple lah, Lysol, or you can do your alcohol. This is completely sterilized lah, Plaswise and lab insurance. Okay, media preps. Sekejap ya. I think this we will go in detail in terms of media preparation, understanding media with Dr. Nick later on in your lecture classes. When is your lecture? This week for group 2? Tomorrow, yeah?
Later.
Later today?
Yeah, at 2 p.m., doctor.
All right, 2 p.m. Great. Do you have any idea what sort of topics he's gonna lecture today? Media, yeah. No idea.
Not sure.
Okay. All right. So basically, do you have? I'm not sure whether you're preparing the. Okay, you will prepare the media. You akan, depending on sort of media that they ask you to do, but I think that you will prepare. Let me check. Growth medium, synthetic growth mediums. Okay. Synthetic growth medium from tail, potato dextrose. PDA. All right. Okay. So basically, okay, what it says is, okay, but media ni is like, okay, let me explain in terms of very layman's term. If I were to grow you guys, if I were to take care of all of you guys, I have to give you food, right? With food, then you all can grow, correct? So basically, if I give you a normal common food like chicken and nasi, semua orang akan makan, betul tak? Normally lah, chicken and rice. Everyone will, there's no issue, you all will grow happily. But in terms of media, they have ability to select a few. All right. For example, Nanti I'll go to introduce. Okay, this is the function of media. For example, katakanlah I nak someone that okay, I want someone that is quite adventurous when it comes to eating. Okay, so I give you fermented food. I give you tempoyak, I give you belacan, I give you cincaluk, those kind of things. Okay, some of you might like it, like crazy about it, and some of you might not like it, biasa-biasa, and some of you might dislike it at all. So what I do, I bagi this kind of food and I see siapa and I buat survey. Okay, orang 3 orang ni suka ni macam biasa-biasa, ini macam tak suka langsung. So now I'll separate you guys based on fermented food. Okay, let's say I want to separate you guys in terms of Western food. I give you steaks, right? Some people like it, some people don't. So based on different, based on different kind of food, based on countries, whatever it is, I'm able now to understand you guys. Oh, dia ni suka makan fermented food, a little bit Western food. So dia ni is this type of people yang slightly fusion Asian Western. Macam dia ni memang Melayu kampung, makan ayam goreng, makan masak lemak. Do you understand where I'm going with this? So the media is not just only to grow you guys, but able to isolate or differentiate you guys based on your characteristics. Faham tak? Get what I mean?
Yes.
Faham tak? Okay. So that's the idea of media. Okay, and then media ni they have different kinds of types and characteristics. Okay, when it comes to basal media ni like I said lah, basic macam beef extract, yeast extract, and peptone. So usually when it comes to composition of this complex method, macam it's like macam you masak macam like a bundle of food. Okay, macam not food. Okay, like the beef extract ni, you know the beef extract ni will grow the microbe, but you don't know what exactly how many protein is there, how many sugars is there, how many salt and pH is there. All you know this particular thing, beef extract, yeast extract, are working and it able to grow you guys, but it doesn't necessarily able to differentiate you guys. So when it comes to synthetic medium, synthetic means that everything is fully made. Okay, you know what sort of carbon sources you put, glucose or lactose or fructose, how many grams, nitrogen, what sort of nitrogen sources you put, yeast extract, egg albumin, what else, soy extracts. Okay, you know those kind of things. How many, what grams, what's the concentration, what's the percentage of concentration of the proteins, how many pH you put, I mean you set, any other kind of minerals or vitamins involved. Everything is being formulated. Okay, this is usually to select a few types of microbes. Enriched medium. Okay, enriched ni macam you perkayakan. Contohnya macam susu baby tu kan. Susu biasa enriched with vitamin A, vitamin C, minerals, this mineral that, so that the babies will grow much more faster and more efficiently. Yes, the baby can survive in, no babies, okay, the microbe can survive in basal medium, but if we enrich, okay, kita supplement it with all this kind of goodies, somehow they will grow much better. Sama macam korang, okay, I give you chicken every day, at the same time I give you supplements, a good supplements. Sometimes I treat you with chocolates, I treat with you with vitamin A, fruits and everything. You will grow, but you will grow at much more better rate as compared to your peers and colleagues or peers and classmates that did not been given all this enriched medium. Maybe badan you lagi tough ke, lagi tinggi ke, lagi muka lagi cantik, kulit lagi putih, I don't know. Right? Much better. Okay. Selective medium. Selective medium meaning you are selecting one microbe compared to the other. Like I said, I nak select orang yang makan tempoyak je. So what I do? I give you tempoyak. Tak sama makan. Siapa yang survive means that particular person likes tempoyak. Siapa yang mati tu, mati tu yang does not survive or did not like it, say they will not grow on that media. Okay. Differential medium, it's more or less similar. Selective medium is like more to select one the other and to eliminate the others. Differential medium is like, I want to separate you guys. Okay, when it comes to microbes, when it comes to media, sometimes they create colors. Okay, If the color you turn green and the color turn red. Okay, this turn red is maybe E. coli, the one that turn green might be Salmonella. Okay, they will both grow, but they will grow at different kind of physical appearance. Okay, that's how differentiate it. Okay, in terms of differential media and selective media, they have different kind of indicators, different kind of selective things that will make the that would make whatever that you selected or want to see or differentiate become visible. Okay, adalah dia punya mechanisms tu. That one you have to understand. Okay, faham tak in terms of media? I think this will be further explained by Dr. Nick in your lecture later. I'm not sure which lecture. Maybe week 2, 3, or 4. Can't remember. Right, any questions so far? Alright, I reckon tak ada no questions. Okay, this will be your methods. I think you will do all these experiments. Okay, you will do the first one, general growth medium. Okay, you just weigh all these things je. Okay, nanti follow je instruction from Kak Teha Katina. Okay, you weigh all this and then you will put in a bottle. Okay, 1 liter bottle or 100 ml flask, a bottle flask. Okay, and then you are all your media will be alternative. I think you have to come. If I'm not mistaken, you have to come back to check your media. Media you buat today, sorry, you buat esok. Maybe on Thursday you have to come back and check on your media. Okay, whether it's contaminated, non-contaminated. Okay. So ni senang je, everything just weigh. Okay, nanti diorang akan ajar how to weigh it. Okay, and then you will do synthetic growth medium. Okay, nampak the difference between synthetic and this one. See, this one you spectone, beef extract, yeast extract. God knows apa compound dalam ni. But we know we use beef and extract. We don't know what's the exact composition of minerals of proteins within the beef extract. But when it comes to this, okay, glucose, sodium chloride, magnesium sulfate, everything is by the dots and designed accordingly. Okay. Sama juga. Alright. And then you have synthetic growth medium. I mean, this is commercially obtained. You tak buat sendiri. Basically, dia dah set dalam bottle. All you have to do, you just weigh je. And then autoclave. That's it. Mostly memang sekarang semua macam ni. Okay. And then you have PDA, called potato dextrose sugar agar. Okay, when it comes to PDA, usually PDA, most of the time PDA ni only used to grow fungi, kulat. Okay. Ini sama juga, this is called basil mediums. Okay, use potato extracts. Okay, dalam potato ada sugars. Alright, sugars bukan sugar lah, sort of glucose lah. Okay, and then you have dextrose, which is sugar juga, and agar. And then you put in bottle and autoclave it. Okay. I'm not sure whether you are using like potatoes ataupun kita ada juga macam commercial obtain a bottle of potatoes, and then kita just take the powder je and masuk and wait. That's it, and letak air and autoclave. Simple as that. But I'm not sure whether you are cleaning or peeling the potatoes. I don't think so. So based on this is what called conventional methods, whereby you are bashing your potatoes and then you create your own media. But nowadays kita ada PDA, agar ataupun memang commercial obtain. Powder je, macam buat susu. Panaskan, nanti dia cair, masuk air, combine water, dilute in water, and then you autoclave it, and then it's ready to be used as a media. Okay, so this one agar lah. Okay, growth medium. Some of it is liquid medium, some of it is agar, depending what you're using. Okay, I think they will show you in detail tomorrow. Okay, so you will see here picture and observation. You're going to use this table. Okay, remember how I taught you how to prepare a table. This is not correct way to prepare a table, but it's just a guide for you. No horizontal lines, yeah. So growth medium, sterilized and unsterilized. You have to put pictures over here. Okay, put pictures before and after, unsterilized and sterilized. Okay. I'm not sure whether you're going to do all this. Okay, 1, 2, 3. Okay, for all of these, okay, for table 1 and table 2, you have to share your. I don't think you would do it all. If I'm not mistaken. Hold on. Okay, double check tomorrow. I will double check with them tomorrow, but ask them tomorrow. I don't think you all have to do Kejap. Commercial synthetic medium. Okay. For this one, you might be given different synthetic medium. For group 1, group 2, group 3, group 4 lain. But the rest ni sama lah. Macam PDA, your basic medium ni, I think you'll be given sama. But for commercially ni, mana dia? This one, you might be given different kind of bottles or synthetic group yang lain. Okay, so there's reason why we have group 1, group 2, group 3. So you have to, for example, group 1 dapat synthetic medium on McConkey agar. Contohlah So you will write the functions over here, and then you have to have before and after pictures. Okay, medium appearance after mixing. Okay, and then group 2 akan dapat different kind of media. Group 3 will get different kind of media. And after you all finish, you all have to share with each other your results. Okay, the functions and medium after mixing, color and the pictures lah. So this one you can share with everyone. Okay. As this one, table 1 ni, I think you will do it individually. I mean by groups lah. You all have your own. But this one only satu saja. But share with you. Meaning that for one group, everyone in each group, korang mesti ada all this media that been given to you. Okay, any questions?
In the procedures of A, B, and of A and B, the last sentence it says combine the results with the other groups. What does that
Mana
mean?
ya?
A and B punya procedures, number 7.
This one.
Yes, the last sentence. of
Combine
the
result with
question.
other groups. I think you would do it on your own for this one. Okay, double check tomorrow. You might be given one group will be given one each of these. Okay, but I think particularly you were given this yang berbeza. Lain semua sama. If I'm mistaken, but I might be wrong because this has been a year already since we last do it. You might be given, for example, group 1 might be given this one, group 2 might be given this one, group 3 might be given this one, and you might combine it. That's what it meant. Macam table 2 tu lah. Combine means you have to share with each other you punya results. Not only your results saja. Okay? Your discussion result, everything will be written by groups lah, but you punya results tu, you have to share with others. So everyone must all have all these results. Not meaning you buat ni, ini je result. No, you have to have everything juga. So get it the result from the other groups, and then usually when it comes to combined result, katakanlah group 1 take result from group number 2 for this particularly experiment, you have to acknowledge them. For example, this result is being taken or is being given or is being taken from group number 2. You have to note for which group you dapat this result. You need to acknowledge their work, and at the same time, you're not doing this work, but you're taking for other results, acknowledging them. Okay, so you have to do that. Jangan lupa acknowledge, sama macam citation. Okay. All right, any questions? A bit blur now, but you will, once you see the experiment tomorrow, it slowly become clearer to you, and they will help you, of course. Just tanya je. Any question, guys? No questions? All right, shall we stop here? All right, thank you very much. I won't be seeing this week. If I sempat, let's see if I'm able to come up tomorrow. If not, I'll see you next week, okay? So I expect better participation. I think it's a limitation from online classes, but I expect better participation from you guys next week lab. All right, is that okay? Fair enough?
Okay, sir.
Doctor.
Okay, thank you very much, guys. I'll see you next week. So be
Thank
safe
you.
tomorrow.
Thank you,
Wear
doctor.
properly. Don't forget your lab coats. Yeah.
Okay, doctor. Thank you, doctor.
Thank you,
All right.
doctor.
Thank you.
Thank you,
Okay, guys.
doctor.
Bye bye.
Thank you, doctor.
Thank you, doctor.